It is always very important to detect whether a quadratic expression is perfect. Remember, I told you if you have, for example, x squared minus 8x plus 16, how can you determine whether this is a perfect squared or not? You should take that coefficient of x, which is minus 8, divided by 2 and square everything. Remember, this is going to be minus 4, right? Squared. And this is what? 16. Oh, which is the same thing as the constant. So whenever you take half of the coefficient of x, you square that, and the result is the same thing as the constant, then that expression is perfect. So it can always be factorized as x, half of the coefficient of x, which is going to give us minus 4 squared. So this and this is the factorized version of this. So the question is, what if we have a leading coefficient and your teacher told you that that expression is perfect? For example, if I have 4x squared plus 4x plus 1, you cannot just take the coefficient of x, because the coefficient of x here is what? 4. 4 divided by 2 is 2. 2 squared is 4. But you can see we have 1 here, so it doesn't work like that. So instead, you should find a way to write the coefficient of x squared as a base to the power of 2. We know that 4 is the same thing as 2 squared. So just express 4 as 2 squared. That is the first thing to do. So if 4 is 2 squared, you can combine the coefficient and the variable to have 2x squared. You see that? 2x squared will give you 4x squared. But remember, we used to have x here and x here. So now, literally, mentally, you should consider 2x as just an x. Therefore, even the middle term must contain that 2x. Yes, 2x. It must contain 2x because now 2x is your variable. So what can you multiply by 2x to get 4? Definitely 2. So it's like having x squared plus 2x, then plus 1. So now you test. Half of 2 is 1. 1 squared is 1. Therefore, this is a perfect squared quadratic expression. And how do you factorize it? You know, you take x, then half of the coefficient of x. But this is serving as x. The whole of this, 2x. Then half of this is 1. Everything squared. And hence, this and this are equivalent. This is the factorized version of this. So whenever, provided that is a perfect squared, always find a way to write the coefficient as a base to the power of 2. Even if that number is not perfect. For example, if you have 3x squared, you can write this as square root of 3 squared times x squared. Later on, you combine the powers to have square root of 3x everything squared. Now you're going to treat square root of square root of 3x as a single variable mentally. Yes.